Okay guys, welcome back. Once again, this is Mr. Hawkins in the flipped classroom. Today on this VOD we're going to be discussing density, and density is a physical property. We talked about it in the last VOD, but we need to go a little bit more in depth on density. Density deals with math, okay, so I'm sorry. We do have to have a few math problems on this. You will be provided with a calculator, and it'll be fairly easy to do. So what do we need to do here? What is density? How do we calculate density, and what is it? It's actually a really tricky physical property. So it actually is the reason why wood will float on water, but certain rocks actually sink to the bottom, and that is all due to density. It's a measure of how much stuff there is. Remember that the stuff is matter, and the space per unit of space, right? So the space we're talking about here is the volume. So how much matter there is, how do we measure that? With mass per unit of volume. Does that make sense? So on the two examples over here on the right, you can see one of these cubes is highly cluttered with molecules, and the one on the right, on the other side has very few kind of hanging around. And so which of these would be the most dense? Okay, we have the most stuff per unit of space. The space is exactly the same. Which one of those two has the most stuff? It will be the one on your left, correct. So the one on the left is more dense because it has more molecules per unit of space. All right? So there's a formula for density. Density is equal to mass divided by volume, or M over V, okay? I'll show you an interesting way of remembering that. So we're going to get algebraic on that. Let's get mathematical, right? Yeah! All right, so let's do an example with density. So here's a sample problem. It says a piece of wood with an irregular shape has a mass of 13 grams. After utilizing water displacement, its volume is found to be 1 liter. What is the wood's density? So, alright, so we're dealing with wood here that has a volume of 13 grams, or a mass of 13 grams and a volume of 1 liter. The units for grams are always, or for density, are always grams per milliliter, okay? G per ml. So, as you can see, the mass is currently in the correct unit, but volume is off, okay? Volume, as you can see, is in liters. It is not in milliliters as it needs to be. So we need to do something about that, and the best way to do it is to convert, right? So if we have liters in the middle and milliliters on the right of our little stair that we still remember, okay? How many times do we slide it? 3. So we'll slide the decimal 3 times, giving us 1,000 milliliters, all right? So we have 1,000 milliliters. We also have 13 grams. So if you remember the formula from the other page, density is equal to mass divided by volume. An easy way to remember that is D is equal to heart, okay? I'm not really good at drawing hearts, but as you can see, we have an M on the top and we have a V on the bottom. Pretty straightforward stuff, right? Anyway, so density is equal to mass divided by volume. The mass here was 13 grams. 13 grams divided by 1,000 milliliters. Okay? Now this is going to give you a very small number because we have a very large volume on the bottom, right? Okay, so how do we do that? We just plug and chug in your calculator and it'll give you your answer. Okay, so the answer I'm getting here is 0.013 grams per milliliter. All right? Do not forget your units, okay? Once again, no naked numbers. That is vital. You always keep track of your units inside of the equation and always keep track of them at the end. It'll help you out in the long run, all right? Once again, remember the units of density are grams per milliliter. They're not anything crazy. So make sure that whenever you're doing a density problem, we have grams, not milligrams, not kilograms, not centigrams, anything like that. And you're dealing with milliliters, okay? Grams per milliliter, not grams per liter, okay? You'll see a multitude of ways of doing density problems. This is just one example. Whenever we come to class, we'll do a multitude more of density problems, and we'll also construct a density column. So if you have any questions, please feel free to add them in the comments section below or come in during activity period. I'm always there for you guys, okay? Have a great evening, and we'll see you later.